Hi, this is AD5NL. I just figured I'd give you a quick tour of the workbench. You can see work's been done here recently, and I'm probably better at tweaking things than I am at cleaning, so it's kind of a mess. But anyways, let me show you what I've got going on. This is my Lime SDR here in an aluminum case. These are the clock input-output here. I've got an old CPU fan. I've run that to the, it's really the external quote-unquote power rail, but it's basically a 5-volt power rail. And then, here on the other side, I've got the receive. Basically I've got my, wide, low, high, and then top is channel 1, bottom is channel 2. So you see here, I've got this hooked up to low 1, an old military LNA, which I bought at a ham fest. And it turns out to be really good for HF, helps overcome the lack of sensitivity of the Lime SDR on HF. Now I did do Easy Fix 1, which involves popping out an inductor or something. It's been a while since I've done it. Off the board, which helps a bit. When these originally shipped, they were basically deaf. Now they're useful, especially if you've got a preamp. On the transmit side, I've got this hooked up here to a box that I built. I don't know how to describe it any other than that. Basically, we've got one of these little Chinese 2-watt amplifiers, as well as a switch, which I got from the Austin QRP Club for, I don't know, $12, $15, something like that. So, basically, this is the common, this is the transmit side, which is normally open, and then the normally closed, which is the receive side. So, the switch controls both the power on the amp as well as the switch. Receive, transmit, and then I've got kind of a hybrid mode where, the bottom of this 3-position switch is amp on, but in receive, and then on the other side of the box, there's the binding posts to the 12-volt power supply, but and I should probably mention it's a 5-volt switch, but a 12-volt power supply, so I've got a DC to DC converter in here. But anyways, on here I've got, you can kind of see it, I know it's dark. Anyways, I've got an audio jack that I can use to control this box, remotely when it's in hybrid mode. Unfortunately, when it's in hybrid mode, the receive signal does go down a little bit. I think probably because, and I'm not 100% sure, but I think it's because I'm powering both the LNA and the amplifier off of the same power supply, and it's only a 3-amp power supply, so that may be drawing too much current or something. But in any event, I need to experiment with that more. I've got a mini circuits 10.7 megahertz filter here on the common, which filters both the receive. It's a low-pass filter, so it prevents the SDR from picking up a bunch of FM broadcast junk, as well as filtering the output when I'm in transmit mode, to prevent from having, the second and third harmonic, break FCC rules, which is kind of important when you're going from 10 milliwatts, which is, 10 dBm or something, whatever this guy puts out, potentially up to 2 watts, which was 33 dBm. Filtering, it's your friend. Anyways, software-wise, here I've got SDR Angel. This is not the most. This is most or second to most recent build, 3.8.2. Currently, it's 3.8.3, which I need to download. Edward, the developer, I think is doing a pretty good job. So with the Lime SDR, first you have to, set it up as your source, and then you have to add a demodulator. And what's really cool, something I just kind of figured out tonight, is you can have multiple demodulators running at the same time. So here I'm looking at the 40 meter, the 40 meter sideband area, and I think there's a contest going on tonight. So if you added multiple demodulators, By the way, when you go to the SSB demodulator by default is in USB, so to change it to LSB, you have to change bandwidth to a negative, which is kind of weird. I wish there was just like an LSB button, like you'd see on most transceivers, but beggars can't be choosers. Anyway, so you can have like that guy and this guy both being demodulated at the same time. I know the frequency's a little off. I think they keep QSYing here, but anyways, so like you could have conceivably, I think I've run as many as 5 different demodulators at the same time. So you could be listening to like 5 different conversations, which granted is a little weird. You can't really make out everything. But, certainly for 2 different conversations, especially when you're only hearing one side of them reliably, which, on HF is something that happens, it might be worthwhile. Anyways, so antenna-wise, I've got a mag loop that I've been working on. So originally I bought this wonderful W2LI loop. Stock, it comes with this, I think it's 8.5, 9 feet. I haven't quite measured it. And I think their documentation may be a little inconsistent, but it's about 9 feet. Let's call it that. Loop made out of LMR 400. The coupling loop here, I believe, is made out of 1/4-inch outer diameter copper tubing. And the heart and soul of it is this. I believe it's 20 picofarads to 360 picofarads variable capacitor. Now, I've been playing around with some other mods in addition to this 28-foot double loop of RG8 that I built. This drops the frequency range considerably. So with the standard loop, I can receive something like 6 megahertz up to about 18 or 19, which is good for covering like 40 through 17. Maybe 60 if you're lucky or something. But with this guy, I've been able to receive 80 meters pretty well. I've even picked up a few signals on 160. And also the upper part of the AM medium wave broadcast band comes in really nicely. So for AM DXing, that's good. But how do I get this kind of frequency range? So I'm fibbing a little bit. Without any changes to its current state, it would roughly tune like 2.5 megahertz up to about 7.5, and as you can tell, it's kind of at its top range right now, which is usually the most efficient at 40 meters, which is I think part of why we're hearing so many signals. When a mag loop is kind of running at its highest frequency, it's gonna be pretty efficient, probably as efficient as a dipole. When it's running at the lower frequencies, it's not quite as efficient. Better than a ham stick, better than a light bulb, but I mean, it's definitely a compromise antenna when you're talking about 160 meters or 80 meters on 28 feet of coax that is like in a 4-foot loop wide, diameter. So anyways, back to the mods. With capacitors, you can increase the capacitance by putting capacitors in parallel, and you can decrease the capacitance by putting capacitors in series. So I drilled some holes here. Originally I had some toggle switches, but I drilled some holes here, made some binding posts here. These are wired up in serial, so like the signal would kind of come in here on the loop, then it's kind of wired to here, and then to the capacitor. And then from the capacitor back over to here. So this bridges it, so it basically is kind of a 0 picofarad, or whatever. But in any event, I can put a small value capacitor here, which basically puts that in series, take the bridge out and then put one of these, little module things that I built. Here, that drops the capacitance and increases the range. So normally, as I said, I think it's like 2.5 to 7.5. But when I drop about 2 picofarads of capacitance right here in series, that increases the top range up to around 10 megahertz. So I can get 30 meters on here, and it's pretty darn efficient as far as I can tell. I mean, I've heard quite a few signals. in receive mode, and when experimenting with transmit, which I'm not going to do on this video, but when experimenting with transmit, I think I'm overloading the receiver over there, on my shelf. I think I'm overloading it, with just a couple of watts. So it's got to be doing a decent job. At 80 meters, of course, it's a lot less efficient. But anyways, so reducing capacitance here allows me to increase the frequency range upwards, and then downwards, I can put a capacitor in parallel, which greatly increases the capacitance. So like, if I were to take this guy here, which is one of our, this is the 320-ish, because I've got a 100 and a 221 in parallel. But I plop that in there, and that's going to increase the maximum range on here from like 360 to like 680 something, I think. And that allows me to tune in and receive 160. And then, throw on more capacitance, and you get into the medium wave broadcast band. Of course, the efficiency, as I noted, drops really quite a lot as you go lower. And I don't think I've ever been able to receive signals at all, even in the AM broadcast band, lower than about 800 or 900 kilohertz. So, there's definitely limitations to that. But at the top half, like 1100, 1200, 1300, I'm pulling in like a signal like every 10 kilohertz, which, I don't think you can do on a car radio. So, on these winter nights as it gets cold and the delayer, disintegrates at night, I'm looking forward to pulling in a lot of states. One of my hobbies before I got my ham license was just tuning around on the AM radio, listening to see what I could hear, and so that might rekindle that. So anyways, enough babbling. This is my cool setup. This is what I've been doing. And I hope that this maybe inspires some ideas out there for other people. Thanks. Bye.